This is page 68, number 10. Hillary and Dale leave for a camp, or leave camp and go for a long hike. So they go 7 kilometers due east. So let's go here. Call it 7 kilometers. And this is north, south, east, and west. So they go 7 kilometers due east. Here was the camp. Okay, and then they turn and go another 8 kilometers in the direction of 60 degrees north of east. So what this means here is if they're just going in this direction towards the east, now they're going to turn and go 60 degrees to the north of east. So they're actually going to turn this direction 60 degrees. So they're actually going somewhat like that.
Wait, why wouldn't they go 60 degrees the other way?
Because they're going north of east. So 60 degrees, they were going east. They were going east, so they're going to turn, and now that's a 60-degree angle to the north. If they were going to go 60 degrees to the south, it would be like down here.
60 degrees to the west, like I drew it.
Well, I don't think you can go. You can't go east 60 degrees west of east, because west is the other direction. You have to either go up or down from the east. Okay, so that way, now we have 8 kilometers there. Again, not to scale. Let's erase that and put it on the other side here. So we have 8 kilometers here. And the first is that they're going to return to camp along a straight path. So something like that. How far from camp are they? Well, we could go 120 degrees on this side. The problem with doing it this way is that in order to solve a non-right triangle, which is what this is, you can use a law of cosines, which will work. The thing with the law of cosines is, I usually don't memorize it because it's so long and kind of arduous. It's not hard. It's just plugging in an A, B's, and an angle, but it's still not a fun formula to use. So I figured there might be a better way to do this. Cassie.
When they're saying like how far from the camp are they, is that asking like kilometers?
Sorry, asking you what?
Is it asking in kilometers how far from the
Yes, so if this is 8 right here, what's this length right here in kilometers? So what I did is I said, well, what if I see a 60-degree angle, I can just make a right triangle right here. What's this degree up here now?
That would be a 30, 60, 90.
A 30, 60, 90 right triangle. So if this length here is 8, what would this length here have to be?
Would that be 4?
That'd have to be 4, because it's half of the hypotenuse. It's a short side of a 30, 60, 90 right triangle. And what would the height of that red
Root
line be? Yes, it would be, what, root 2?
No.
4 root 3. Yeah, root 2 is on a 45, 45, 90. So that height is 4 root 3. Now that made life a lot easier because I have this length, and that length to find. So I can use Pythagorean theorem.
length, too.
What's that? Yeah, because it says how far from camp are they at this point. So I'm going to go 11 squared plus
7 plus 4.
4 root 3 squared equals x squared. So that'd be 121.
So that changed to 16 root 9.
It changes to 16 root 3. Sorry, yes, 16 root 9.
Yeah, 'cause-
So 16 times 3. Yes, 16 times 3. That's 48. Which is, that's a nice number.
Which is 13.
Which is 13. So x is 13. That's how far from camp they are. Okay, now, the second part actually has a few different possible answers. It says use an angle to describe the direction that they have to follow to reach their camp. So the first thing is we're going to need to find some angles. I would just say let's find this angle right here, and we can build off that.
Yeah, because you already have 30.
Right. So how would I find that angle with the sides that we have? We have all 3 sides of this big right triangle right here. Do you want to do inverse tan? So let's do inverse tan of what?
Oh,
11 over 4 root 3. That will work.
Would it be easier to do like sine?
I would have used sine, yeah, because sine, Kyle, why would you use sine?
Why?
Yeah,
So you don't have to use the 4 root 3.
right, so inverse sine of 11 over 13. And here's what happened in the last class. When they typed into their calculator this, because of a parenthesis issue, what it did is it did inverse tan of 11 over 4, and then multiplied that times root 3, instead of having root 3 in the bottom here of the denominator. So that's why I would keep it in this form right here. I would use sine. When you do that, what do you get? Like 50,
57.79.
oops, that's a bad 5. 57 point,
79.
so 57.8 degrees. Let me do that. 57.
Why did you need to find the degrees?
Is that the total angle?
That's a total angle. Now, because it says, yes, it says use an angle to describe the direction. Now,
So would you just subtract 30 from that 57?
if you wanted to find this angle right here, that's what you would do. The problem is it's saying to use an angle to describe the direction. So, I guess you could say, if you subtracted, what you get, 27.8, you would say 27.8 degrees.
Southwest?
No, because it's from your direction you were just traveling. That's why I wouldn't use that. I guess you could say 27.8 degrees to the north of the direction I came from, but that's confusing. I would use a whole angle. I would say either it's 57.8 degrees and it would be to the west of south. So what that means is if I'm facing south, if I'm facing from this point, I'm facing to the southern direction. If I go to the west, 57.8, that would get me on the right track. That makes sense?
Yeah.
Or I would say, I would find this angle right here, which would be 22.2 degrees, and I could say it's 22.2 degrees south of west. So if I'm facing west here, if I'm standing here and I'm facing this direction, and I go in the southern direction, 22.2 degrees, I'll be going the right direction.
Wait, why 22.2?
Because I subtracted that from 90 to get from the west to the south. So you could either go to the, west of south would be starting south and going to the west, or if I started west and moved to the south, that is called south of west. So it's an interesting idea here when it comes to like orienteering and reading a compass.